Hi class. Here is our lesson on the parabola. And so what I want to call your attention to first in the book, this is the derivation of what we call the formula for, or the equation of a parabola. And this is more general than the other ones that you know. This picture here is very important that you know these pieces. So every parabola, we already know, has a vertex. This whole section was about the conic sections. And so it turns out if you cut a cone with a horizontal plane, you would get a circle. If you cut it with an angled plane, you would see an oval. If you cut it with a plane like this, you would see a hyperbola. And if you cut it perfectly kind of parallel to this, you would see just a parabola. So you wouldn't get the ones that show up on both sides. That you need to cut it straight up and down. So all of these shapes that we've been graphing come from the different ways that you can cut a cone with a plane. So then over here, you know, almost everything that we had a center and it had focus or foci. A hyperbola had two foci, an ellipse had two foci. A center doesn't have any, it has a center instead. And a parabola doesn't have two foci, it only has one focus. And so you have your vertex and your focus sits up there. Right on the other side of it, so equally, and this you're going to find out this value right here is what we call P. So that distance is P, and that distance is P. And so on the very back side of the where the vertex is, you have what you call a directrix. And what that does, and how we actually derive this equation for this, is we say a parabola is all points, so here's a generic point xy, so that the distance from the focus to that line is the same. So that distance is d, that distance is d. If I picked one up here and went there and there, that side should be about the exact same length as that side. If I took one there and went there and down, however long that is should be however long that is. And since this length should be the same as that length, then if that's P, that's P. So they kind of sit on opposite sides and the parabola runs in between them, if you will, so to speak. But now look at this, this, and this, and look at these distances that we have here. This distance is slanted, so we're going to use the distance formula on it. I'll show you in just a second. But this one, if we went y off the ground here and we went p below the ground there, that's y and that's p. So that piece should be y plus p. You could also get that by saying the top value minus the negative, or the bottom value, and the top value minus the bottom value, it makes it plus. And so that distance is y plus p. So that distance should be y plus p. So if you look in here, we're using now the point 0p and xy, so we're using this point and this point. The distance formula, x2 minus x1 squared plus y2 minus y1 squared. X minus nothing is just x, so it's just some cleanup right here. Now we know what it should be on the other side, so this distance here is like that distance. This distance is like that distance, and so I'm just saying those two distances need to be equal. Once you have that, square both sides, and you can work the work out from here. So this is the derivation, though, for how we come up with the equation of a parabola. The final thing that they do talk about sometimes is this piece that runs through the focus and runs over to the edges. That's called the lattice rectum. And we know how long the lattice rectum is, and so this is important. And sometimes a clue, you'll see the types of problems we're going to do, but sometimes the clue in there, they'll say the lattice rectum has length 8 or whatever, and then, but they're telling you something in there. And here's how you know what it is. So if I go from from the focus to the line, that's P and that's P. So if I go over here, remember that whatever this distance is, this distance has to be the same, right? And so if this is 2P, then this has to be 2P right here. And this has to be 2P right there. And so the length of the lattice rectum itself is 4P long. So just keep that in mind, okay? Now, I'm going to skip over this. You can read this, but I'm skipping it for now because I'm going to show you how I do the problems, and then we'll come back and see how it does all fit in with this. This is if it's centered at the origin. It's kind of the more bland case. A couple pages further, we get the one that's centered generic. Here's the thing to note and to really, really remember. In this case, this is not how we usually think of parabolas. And what I mean by that is a parabola is usually y equals ax squared plus bx plus c. And the thing to notice is the x is squared, the y isn't. But in this, the y is going to be squared, but the x isn't squared. So this is the opposite of how it normally goes. Those are what produce these sideways parabolas. But this is basically y on this side and x squared on the other side. So this are the up-down parabolas. What makes them go up or down? If this is positive, it'll go up. If it's negative, it'll go down. If it's a sideways one and it's positive, it opens to the right. You see that P being positive, 4 is always positive. So if P is positive times 4, that will be a positive, and it opens to the right. If it was like Pac-Man or whatever, he'd be going that way. If P was negative out here, well, that means less than 0, and a positive times a negative number would be a negative, and then that makes Pac-Man go to the left. So what I look at in here, and this is the distinguishing feature between ellipses, hyperbolas, and parabolas. The ellipse had an x squared plus a y squared. And yeah, they were over a squared and b squared, and it equaled 1. Or they were x minus h squared, and so on and so forth. The big thing was it was an x squared and a y squared. There was a plus in between them and a 1 on the other side. That makes an ellipse. For a hyperbola, we had an x squared over a squared minus y squared over b squared equals 1. So in this, they're still both squared, but instead of a plus here for the ellipse, we now have a minus there. And since that's a minus, that's the only given trait that clues me into it's not an ellipse, it's actually a hyperbola. And then, if it's neither one of those, if one of the variables is squared and the other one isn't, then it is a parabola. And if it's y equals something with x squared in it, it opens up and down. And if it's x equals something with y squared in it, then it's a left-right parabola. So we will come back to this page after we do a couple problems. And then I'm just going to show you in here. I talked about this in one of the last videos. This does reflect all of the rays perfectly. If they come in at a right angle, it will shoot them. And this is how a satellite dish actually works. So that's kind of neat. Okay, here are your problems, and I'm going to tell you what I've done. I've worked out problem 18, problem 24, problem 48, and problem 54 for you on a different sheet. And with those, I have them written down and everything, and I have them worked out, so I'm going to explain them to you, and then we're going to come back to this page in the book, and we will compare what we found without using any of this to how it actually is. Okay, so to do that, I'm gonna pull this out, I think, and put it side by side, and then I am gonna just leave it off. Okay, so here we go. This is problem 18. Now, problem 18, all that's given to us is this right here. And here's what I'm doing. So I want to tell you this right now. In problem 18, it says, rewrite it in standard form. Well, 18 already is in standard form. Then determine the vertex, the focus, and the directrix. But notice it doesn't say anything about graphing or anything about the latus rectum or anything about any of that. And so all you would have to do, I'm going to do more than what the problem's directions actually states. But I'm doing it so you can see it in every example, and then you take what the problem is asking you for. I hope that makes sense. Because down here it says label the focus and the directrix, but you graph it finally. And here it doesn't say anything about it, just find the equation based on that information. And here, given a picture, find the equation. So all of those have slightly different instructions to them, but I'm going to kind of model them all the same way. So in 18, this is the statement of the problem in 18. And so what I can figure right away is this. It's a y squared, so the y is squared. The x is not, it's to the first power. So since that is not a y equals x squared type thing, which I know to be an up-down parabola, I know this is a left or a right parabola. Because this is positive out here, I know it opens to the right. So I look at this. Well, first I look and see who got squared and who's not. And if y is squared, it's left, right. And if x was squared and y wasn't, then it would be an up-down like normal. Once I know it's a left, right, I say, is this positive or negative? And since it's positive, it opens to the right. So my little picture right there is just my clue on how it's supposed to look. Okay, opposite of that, that's with the x. The opposite goes right there. The opposite of that, that's with the y. The opposite of -2 is 2. That goes in the y slot. Can't make it any easier than that to get the vertex for that. Then, this out front, and we didn't really focus on the formulas per se, but all of them have a 4p out front. That's the only constant. Everything else, parentheses, parentheses, and the number out front is 4p. So, this number, 4/5, I know 4p equals 4/5. And then I divided this side by 4, and dividing by 4 is multiplying by a fourth. And so those cancel, and I found that p was 1/5. Okay, so now I know what p is. Now what does p do? Well, here's where I kind of need to go to a picture if I'm not going to take the time to memorize all of the stuff in that table. So what I do in the table is this. So I say, okay, so we have -4 and then 2 like this, and I know it's going to open this way. Now here's what I do. I say, okay, then that tells me the directrix should be over here, and the focus should be in there. And one cool thing is I know whatever the vertex is, that is P, and that is P. Notice that's just left and right P, right? So if I want the directrix, I take the x value of it, which is -4, so I know the x value of the vertex is -4, and I go by left whatever P was, and P happened to be a 5th, so notice this is my directrix right here. So that is my directrix right there. Then the focus. So now the focus comes the other way. So I know that I'm 2 off the ground, so I'm going to stay 2 off the ground, but I went from here right by P. So I go plus. See, I go minus there to get on the back side and plus there to get on the right side. And I know what P is. Then the endpoints of the lattice rectum. Because this is 2p, this has to be 2p right there. And that means I now know what coordinate this is because it's straight up and down off the focus. And so the focus was at -4 plus a fifth. So I have both of those right there. This down here is a fifth. And so, but I go up 1/5 and 1/5. That's 2/5. And so that's why I have those in there. Okay. So just given that, I can take the opposite of that, put it there, the opposite of that, put it there. I can get the vertex. I can take that number and say, well, that number is 4p, and I can figure out what p is. Then based on that y is squared, x is not, and this is positive, it opens right. When I kind of sketch that in, then I can see, oh, my directrix should live there, and I know it's p off of the vertex. Well, that's the vertex minus p. And I know that the focus should be that p right of the vertex, and so it's there. And then once I have the coordinate for the x value for it, I know I go up 2p's and I go down 2p's. And there you have it. So now watch this. Here is that problem. And here's what I've done. I've taken and just graphed all of the points that we have. So we had the vertex here, and then we had the focus, and then this was the directrix, and then these were both endpoints of the lattice rectum. And so there that is. And when I turn this on, you see it does go through the purple, the red, and the black point. And from the red point, the vertex, to the directrix, that is 1/5. And however long that is, it's exactly the same on the other side to the focus. And so there's all the information and how you pull it from that equation. Now that we've done that, let's do this. So I'm going to get rid of that. And okay, here we go. Okay, so on this equation right here, we're in this piece of, it looks like this. And so it says the focus is h. Well, what's h? H is right there. So h should be that, oh, but it needed a minus. So it should be -4. Okay, so my h is -4. And then plus p. Well, that's still 4p, and so that's 4p. So p would still be a fifth. So it should be -4 plus a fifth, comma 2. And so let's see. There it is for the focus right there. Okay, and then the directrix should be h. What was h? H was -4. And it should be x equals h minus p. And p was a fifth. Oh, yeah, that's what I have right there. That's h minus, and that is p right there. So that's that piece right there. And then the endpoints of the lattice rectum here, it's h plus p. And so here's h plus p, h plus p. But then it's k plus and minus 2p. Well, if you double that, it's 2/5. And so there's the plus and there's the minus right there. So all of that information from that line, I was able to extract just by kind of sketching out my basic knowledge of that picture. And that picture that I'm referring to again is the one in the beginning right here that has all of that information on it. And you're going to want to put that that's p, and that's p, and that's 2p, and that's 2p. So that whole thing is 4p, and that's called the lattice rectum, and so on and so forth. So just make sure that you have it down, okay? Now we're going to do 24. So trust me, this is 24 written down, and I don't know what the directions say, and I don't really care. But here's what I do know. I see that I have an x squared and an x, and then I have just a y. So I think I need to complete the square for the x's. And since the x is squared and the y is not, I know it's either an up or a down parabola because the x is squared and y is not squared. There is no other y in there. So I'm going to put this on the other side. It becomes a plus 24y. I'm going to move this to the other side. It becomes a minus 28. Then those two things are the only two terms left on the left-hand side. So I put them down, put a plus blank, because I'm going to complete the square. Well, if I add something to this side, I have to add something to this side. Half of this is negative 2. Square it, it's 4. So I'm going to add 4 to both sides. Negative 28 plus 20, or plus 4 is negative 24, and you can pull the 24 out. This now looks like standard form. So when they say put it in standard form, this piece is what we call standard form. And that is, once I get there, guys, I can get everything. Opposite of that goes in the Y slot. Opposite of that goes in the X slot. This is 4p, so 4p is 24. That means p is 6. Since I see now that that's positive, I now know it opens up. If it opens up, and that's my vertex, I know my directrix is down there and my focus is up there. And I know this is down p and this is up p. So if I want my directrix in there, then this is a horizontal line, and horizontal lines are y equals a number. And how I get that is I take the height, so I was at 1, and I need to go down 6, because I'm going to drop whatever p is, and p happens to be 6. And so I'm going to take 1 minus 6, and it's negative 5 right there. So you can see the negative 5, that's where it comes from. The focus then, the focus up here, I know I go from the vertex and I go up p. And so the vertex is at 2, 1. Well, if I move this up 6, it should be at 2, 7. And there is that focus right there. Now, I know the lattice rectum runs through here. So I know it'll be at a height of 7. And I know it's 2p that way and 2p that way. But p is 6. So 2p is 12. So I have to go 12 that way. Well, 2 minus 12 is negative 10. And I have to go 12 that way. Well, 2 plus 12 is 14. And they're all the same height as the focus right there. Okay, so the big key, complete the square, leave the quadratic stuff on one side, move the non-quadratic stuff to the other, complete the square, pull out your stuff, figure out your vertex and p, and from there, with a picture and knowing the parts, you can figure out everything without knowing any formulas. Notice I've never said what h is or what k is or what any of that stuff is. All I've said is what's p and where does stuff live relative to how the parabola, quote unquote, opens. So, coming over here, if we go in here, that was problem 24. So here's 24. And I'll tell you what I've done here. So there's the directrix. That is one point of the lattice rectum. That's the other point of the lattice rectum. There's our vertex right there. And 2, 7 is our focus right there. Now what I've done up top is I put the starting parabola in there. So I put that version in there. And I put that version in there. And I'll show you what that's going to do for me. When I turn this on, I see there's a red one. That's cool that it goes through all the points. But when I turn this one on, it lays right on top of it. That tells me that the red and the blue graph are in fact equal to each other. And so this is equivalent to that, which means I have the right equation here for it. So there it is. You can see it and go from there. Another problem. So this problem is 48. In 48, it just says the vertex is negative 2, 3. The directrix is x equals negative 7 halves. and they give me the focus. So notice what I've done in this problem. I did go to a graph first because I'm lying to you, but I don't want to memorize all of those things. I want kind of a good way of doing it. So here's my X and Y axis right here. So I went over 2 and up 3. That's my vertex. My directrix sits on this side. So if that sits there and this is my vertex, I know it has to open that way. Once I know it opens that way, I know it's a y squared and an x. So what I did literally right away was I said, okay, well, I'm going to have a y squared and a something and an x. And instantaneously, I could say, oh, that's a -2, so that should have been a +2. And this is a 3, so that should be a -3. Okay, that's cool. And then here's the deal. From here to here or from here to here, that distance, either one is p. So what I've done is I actually, when I worked it out, I said, how far is it from here to here? Well, the x-coordinate of the vertex is right there. The x-coordinate of the focus is right there. And if you want to know how long something is, you do the right minus the left. Or you subtract the 2 and take the absolute value. But right minus left will always be positive. So if I do 1/2 negative, it's right above. But then minus -2, it's 1.5. And 1.5 is 3/2. And so I know right now that p is 3/2. But that's not what goes here. What goes there is 4p. So notice I multiplied by 4. 12 divided by 2 is 6, and that's how the 6 got there, and that's how I'm going to put it right there. So there's that information. I slowed down off this because they gave me the vertex, they gave me the directrix, they gave me the focus. The only other 2 things to do would be to get the latus rectum and or the endpoints of that. And to do that, all we have to do is take the focus's x-coordinate right here, and then take this and add 2 of those and subtract 2 of them. So it should be like 1/2 6 and 1/2 0, I think. So I'll add them in. That problem is problem 48. So here's problem 48. And I just said it should be -1/2, 6. And I believe -1/2, 0. So there is the sketch of my vertex, my directrix, my focus, and my endpoints of the latus rectum. And now I light this up, and it goes through everywhere as it was supposed to. And so I'm pretty sure that it's correct. So that's cool that they just gave me a little bit of information. And from that, and I needed a graph. And the important thing was knowing where's the vertex, where's that directrix, because then I know that the parabola opens away from the directrix. And then when I saw it went right, that's how I knew it was a y squared and an x piece in there. Okay? Final problem is this. And so this one is just a picture in here. So all we had was a picture to start with, and it says just find the equation. And so they gave me the vertex, and they gave me the focus. And they also gave me that it opened down. See, I put that down there. And what that means is if it opens down, it's going to be an x squared, and it'll be a negative and a y, something like that. So I'm pretty sure, yeah, in the beginning here, I went like this. And I just filled that in like this. And I said, okay. And I got that information right there because it's down. If it's down, it's an x squared. And it has to be a negative out front. And then we have the y's in there. Then I look at the vertex right there and I go, oh, if I saw a 5, that would have been a -5. And if I saw a -3, then that would have been because I saw a +3 right there. Okay. Then, all along, I said this is the important thing. This right here, this distance, whatever it is P. That's cool. It's not shown in here, but the exact same distance on the top side would be my directrix up there. And so, what I need then is to know then the value of P is, it would be 5, because that's the higher value right there in the vertex. The lower value is 319/64. So if I pull this in, it's up top there, but 5 minus 319/64, and I'm going to make that a fraction. It's 1/64. So my P is 1/64. But 1/64 is not what goes there. What goes there is 4P. So 4 times 1/64, that kills that and makes it a 16. And that's why there's a 1/16 out front for that. This one, I kind of did this before. It was rather fun when I was writing it up. If I pull this out and put it here, and we open this one at 54, so you can see I just put the couple things that we were given on there. I graphed right here, you can see the 3, 5, and right there I graphed the focus point right there. That's all I had. And then I put my answer in right there. And so this is what I have, and I had to go like way zoomed in to have them separate, because they're so close together that they're basically indistinguishable from a macro scale. But when I put that in there, it was starting to look pretty good. Then I kind of went in here and I was like, oh yeah, okay, there's the separation. And then I got into doing this where I was like, okay, let's see if I scale this and scale this a little bit, maybe scale this a little bit more, a little bit. So there they almost look identical. And those are the 2 points that are graphed there, and that does go through, and it matches everything that you needed. So I hope that helps. And then just to revisit this in the book, you're welcome to memorize this. The big thing is, this is just x minus 0, and this is y minus 0 squared. So this one is always, I think, the ludicrous one, because everything in here is exactly the same as everything in here. Because if h is 0 and k is 0, then that's a 0 and that's a 0. So this would be y squared is 4px. And this would be 0 and that would be 0. So it would be p comma 0. And in the beginning, look, see, it is p comma 0. And it is that piece right there. So this table is redundant anyway. The only table you really need is this one, because it allows for the shift in there. But the big thing for you is remember that it's a 4p out front. And remember that the distance from here to here is p. The distance from here to here is p. That's 2p, and that's 2p right there. If you remember that, and you can tell if the y is squared and it's positive, it opens right. And if the y is squared and it's negative, it opens left. The x is squared and positive, it's up, and if x is squared and negative, it's down, then you're golden. You have everything that you need. And so there are, so just to recap, I did one from here and another one from here, but I did them not just doing the vertex, focus, and the directrix. I also did, I graphed them, and I found the points on the lattice rectum and all of that. Down here, I didn't do any of those because these are really close to these up here, These you'd have to complete the square on. These are already in standard form, and so on and so forth. So I showed you an example of those. I did 48, so any of these in here are along those lines. And then over here, I picked this one out, and so you have a smattering of them worked out, and do your best. Hang in there, and I'm proud of you. All right? Take care. We'll talk soon.